Welcome to a technical analysis of thermal minting technologies in antiquity. This video explores the genesis and craft of cast coinage, the oldest coin production technique. We will examine its global applications and eventual displacement by striking technologies. Casting is a one-step transformation defined by its efficiency. Unlike the two-step process of striking, casting is a singular event using thermodynamics. It involves pouring molten metal into joined molds that bear the negative impression of the coin design. Casting relies on fluid dynamics and mold cavities. Molten metal is poured into a crucible, travels through a main artery called a sprue, and fills the coin cavities. Solidification occurs through cooling within the mold, not impact. To maximize output, ancient molds were often stacked vertically or arranged in branches to form a coin tree. This allowed a single pour to fill multiple cavities simultaneously. Clay molds were favored for their heat resistance and ease of production. Post-casting refinement, or the art of the finish, involved 3 steps. First, the coins were separated from the sprues. Next, the seam, a ridge where the 2 mold halves met, was smoothed. Finally, manual filing removed the seam and sprue marks. Until the industrial age, casting was the only method capable of producing large numismatic items. Striking, which relies on human force, was physically limited in the size of metal it could imprint. Casting bypassed this limit using liquid metal. Casting simplicity had a cost in precision. Base metals like copper and bronze were suitable, prioritizing volume over value. However, the inconsistency of casting made it unsuitable for high-value precious metals like silver and gold, which require precise weight control. The East Asian cash coin represents the most successful application of casting technology, with over 2,000 years of continuous production across China, Japan, Korea, and Vietnam. The square hole in the center was an engineering solution that facilitated simultaneous mass filing. The Roman Republic's as was cast due to its sheer size and weight, serving as a necessity before the shift to silver. Meanwhile, Celtic Potin in Britain and Gaul utilized casting before high-pressure striking became dominant in the West. Casting was a global convergent technology. Examples include ancient clay mold techniques used by the Yaudea in India, Fals in North Africa, and Paitis in Indonesia. It emerged independently, where base metal needs outstripped striking capabilities. Forensic numismatics identifies cast coins by specific features. These include the sprue mark, which is the remnant of the channel where metal entered. Other evidence includes the casting seam and a grainy surface texture from the cooling metal. Casting is a thermal, one-step process relying on gravity and heat, resulting in inconsistent weight and a grainy surface. Striking is a kinetic, 2-step process relying on pressure and impact, offering precise weight control and high-definition detail. Striking eventually won due to greater sharpness and standardization, which aided anti-counterfeiting efforts. It also offered the required precision for high-value commerce. The control offered by striking planchets surpassed the capabilities of pouring liquid metal. Casting was not a failed technology, but a specialized one, the industrial ancestor of mass production. It prioritized volume and utility over beauty. Casting sustained the economies of East Asia for 2 millennia and provided the heavy metal currency of the early Roman Republic.